Now we're going to use those variation equations to find a missing value. So the constant of variations must be equal. That's basically what we were just testing before. The constant needs to be the same for all ordered pairs in that variation. So if x and y vary directly, that means I'm multiplying my x times something to get up to my y. It's being multiplied times k. So here that k needs to be 2. To go up from 2 to 4, that has to be 2. That means this needs to be the same. I need to be multiplying by that same k, which is also 2. So I need to first find that constant, then use that constant variation and the given value to solve for the missing value. So first we need to figure out what type of variation do we have. These vary directly, which means to find my constant, I'm going to do y divided by x, or 48 divided by 12, which is 4. So my constant is 4, which means my variation equation is y equals kx, or y equals 4x. And they're telling us one of the values to plug in there. They're saying, find x when y is 6. So 6 goes in for y, and now I need to solve for x. So I need to cancel out this multiplication. I'm going to divide by 4 and divide by 4. And my x value is 1.5, or as a fraction, 3 over 2. Example 2, they vary inversely. So my constant is going to be found by multiplying y times x, or multiplying x times negative 4. So my k here is negative 32. So I'm now going to use this information with the constant that I just found in my inverse variation equation, which is y equals k over x. If you forget this equation, you can always use this one. They're the exact same thing, just rearranged. I need to find y when my constant is negative 32 and my x value is 16. And so y has to be negative 2. On example 3, the x and the y, they vary directly, which means to find my constant, I'm just going to do y divided by x. So here my constant is 9 divided by negative 3, or negative 3. Now I use that in the direct variation equation, which is y equals kx, or y, negative 21, equals negative 3x, and now I'm trying to solve for x, which means I have to divide. I'm going to divide by negative 3, divide by negative 3, and that gives me that x is 7 in this case. And it should make sense to go from 7 to negative 21, I'm multiplying times negative 3. To go from negative 3 to 9, I'm doing that exact same thing. I'm multiplying times negative 3. And the next one varies inversely. Those are inversely proportional. So to find my constant, I'm multiplying x times y, which means my constant is 42. Actually, I'm just going to use this equation again. So you really can just use that equation. I'm just going to do that. My constant I know is 42. You could also use the other one if you wanted to use this one. But it really doesn't matter. You're just solving for the missing one when you have two of these values, in that equation or in that equation. It's important that you use one of those because those are the inverse variation equations. They tell me that the y is 3, and I don't know my x yet. I'm trying to find the x, but I know to solve this, I would just divide by 3. So x equals 14. And again, that should really make sense because when you multiply these together, and when you multiply these two together, you get the same number. You get that same constant of 42. On example 5, I'm looking at a direct variation. So, My constant can be found by doing y divided by x. So my constant here is negative 18 over 16, or negative 9 over 8. So you could write that as a decimal if you really wanted to. Actually, it might even be easier on this one to use that as a decimal. I'm not going to. I'm going to use that as a fraction still. I'm going to use this constant and the y value in my direct variation equation. So that's 24 equals negative 9 over 8 times x. And there's two different ways I can cancel that out. I can either multiply by the reciprocal on both sides, or I could divide by this fraction. If you're going to do this in the calculator, this fraction needs to go in parentheses. Here, they're just going to cancel out. Here, you need to put this fraction in parentheses. You can do that as a decimal or as a fraction. So x is going to be 64 over 3. It's going to be a negative. Or you can write the decimal, negative 21.3 repeated. Either of those decimals or fractions are okay. And example 4, x and y are going to vary inversely. So that means to find my constant, I do 4 times 11. I'm doing x times my y. So my constant here is 44. And if I'm going to get that same constant, it's 2 times some number to give me 44. I'm going to write that as an equation. I'm going to write that in this equation. 44 equals some number times 2, which means that y has to be 22. On example 7, now we're given a table. And we're told important information in that word problem, or instructions at least. X and y are inversely proportional. That means when we multiply x times y, we get the same number every single time. So x times y is 12. That means all of these, x times y is the same number. It's always going to be 12. So here my y has to be 4. Here it's got to be negative 4. Here it has to be 2. It's got to be 1 there. A half times some number to give me 12. That has to be 24. And negative 2 times negative 6 would give me a positive 12. The constant has to remain the same. So basically all you're doing is 12 divided by x, and that tells you each of the y values. Okay, same exact idea. We're trying to solve for a missing value, so now it's going to be embedded in a word problem. Sometimes they're going to tell us outright it's a direct variation or it's an inverse variation. Sometimes it's going to be more subtle, where you have to decide, is that direct or inverse? Basically, what's the relationship between them? Do they both go up at the same time? If the x value goes up, what happens to the y value? Does it go up with it, or as the x value goes up, the y value goes down? This one is an inverse. This guy is a direct variation. The x and the y don't actually matter when you're solving for a missing value. It doesn't actually make a difference which one's the x, which one's the y. When we're coming up with a function, if you're trying to write an equation for this, then it does matter, because then the independent variable should be your x, and the dependent variable should be your y. If you're thinking of this as a function, then it does matter. If you're trying to write an equation, it matters. But if you're just trying to find a missing value, it won't change your answer if you decide that the dependent variable is your x value. It actually doesn't matter if you switch them. The first one says that the gallons G of water used to take a shower varies directly with the number of minutes M in the shower. It should make sense. Actually, we don't even need them to tell us that that's correct. As you shower more, you use more water. As the showering time goes up, so does the number of gallons of water used. So they both go up together. That's direct variation. A 6.5-minute shower uses 39 gallons of water. How long would it take for you to use 60 gallons of water? You might recognize this problem from last year before algebra. You could actually set up a proportion to solve that. Direct variations are really just proportions. You could talk about this as the number of minutes over gallons and set up a proportion using x over the given number of gallons. We're going to use the direct variation equation, but if you get stuck with this really is just a proportion relationship. So we are going to first find our constant. We need to know what the constant is, and we know that it's a direct variation. So we know we're going to do the y divided by the x. The way I see this, I see the time as the independent variable, so that's going to be my x, and I see the gallons, or the water used, as my dependent. The gallons depends on the amount of time that you shower for. So my gallons is my y. So 39 divided by 6.5 will tell me the constant here at 6. And that means that I can use this in my variation equation, along with the given value, 60 gallons. 60 is the number of gallons, so that has to be my y. It really just make sure that you're just make sure that you're consistent throughout the problem. If you decided that your y was gallons in the first place, the gallons needs to be used as the y again. And I got one step to solve this. I have to just cancel out that multiplication by dividing by 6. So x equals 10 minutes. A 10-minute shower would use 60 gallons of water. Number 2 says the length of the violin string varies inversely as the frequency of its vibrations. I really should say width. The frequency of its vibrations, and that actually should make sense. As the string gets longer, the frequency of its waves gets shorter. So a 12-inch string vibrates with a frequency of 412 cycles per second. What is the frequency of an 8-inch string? So we know it varies inversely, so to find my constant, I'm going to multiply y times x. So I'm going to assign, let's say, the inches, or the length, is going to be independent, and the frequency depends on that. The frequency depends on my length, so my frequency is the y, and my length is the x. When you multiply those together, we're going to get 4,944. And so now I can use that. I'm going to use that actually in this equation with the given value. The given value here is 8 inches. That's going to be my x value. So 4,944 equals the y, which is the frequency, times 8. So to solve that, I would just divide by 8 on both sides, and that would tell me that my y value there is 600 and... I'm going to actually figure that out in the calculator. 618.